Hey there folks, welcome back to another part of my thing where I'm making a Tetris Game Analyzer. Today will not be very much excitement at all. Well, maybe, I don't know. I don't have my Nintendo hooked up. It's been about 7 weeks since I really took a look at this. Yeah, basically since Christmas I haven't taken a look at this code. So this is just going to be more of a reintroduction for me at this code and what the next steps are. I did in sometime last month try and make a drought counter, and I forgot to hit the record button. So I recorded my face, but not the actual screen, so that was kind of funny. And it's okay, because it didn't work out anyway. It was a complete failure, as I kind of thought, because our piece counts just weren't quite as accurate as the rest of the numbers. Something that we could change in the future. But one of the things that I really want to move into is to get the robot announcer, the pieces in for the robot announcer. So I think what we're going to do today is I'm going to familiarize myself with the code, and we'll see if we can start doing some preliminary work on the robot announcer. But what we have here, not the robot announcer. We actually have a few things more to do. Let me see here, because we have analyzing the games, but we want to analyze the session. Many games at once, and we had the IsPlaying flag, and that was working, fine. And if I recall correctly, in our data extractor, in our Tetris data model. So I'll make sure I'm recording here. Everything is awesome. Perfect. We had down here the IsPlaying flag. Right, and so we did, originally when we first made this IsPlaying check, we took arbitrary values from random parts of the screen. And then the last real session that we had, I refactored it to use relative positionings of actual elements. So this is the small rectangle below the eyepiece count. This is the small rectangle where the top score is located while you're playing. And this whole thing checks to see if that current screenshot is actually playing a game. And we were able to use that to actually detect the beginning and ends of games, which is nice. So what we have to do, we have models in our game analyzer. We have a game model, and right now we have score lines, Tetris count, and Tetris rate. And we can update the game model using a Tetris data model, and this is kind of what we do to do that. So we're going to have something else now called a session. But I just want to make sure that I've got this sort of structured like I want it. Everything's in a try-catch loop. Not really great, but whatever. Take the screenshot, create the data model factory, check the IsPlaying flag. See now this if, else if, IsPlaying, data model IsPlaying is false. See, one of the things we want to move away from is having too much stuff in any one given method. And so I'm thinking about moving this check just to something like no, it's all right for now. Not a whole lot's happening. So we check to see if you're playing. If you are playing and you weren't playing, then we're starting a new game. I mean, if you're not playing and you were playing, then your game is ended. That's kind of the simplistic logic that we've used. And then if you're playing, we detect a change and we update the current game. And then we've got this last data model just to keep track of what happened last time, so that if you aren't playing, we still have access to your score and things like that, the final screenshot of your game. So we're going to actually start now and make a new model. And this is going to be called a session model. And the idea here is that a session, whoops, I forgot to put the word model after it. No, that's the game model. What am I doing? You know, I haven't had coffee yet. My coffee's ready, so I should go get some. And this table's janky, wonky. Yes, I would like to rename this. Thank you very much. So this is actually a session model, and this is going to be a series of games. So we're going to have things like something really simplistic, like, oh, just 1 second. All right, I'm back. Okay, what was I saying here? So yes, so the session model is going to be keeping track of how many games you've played. So we're going to have a very simple thing here, number of games. Why am I saying that? Just games played. Oops. Simple, games played. And then we're going to have a list of integers, and it's going to be scores. I wonder if one thing we could do is, because we have access, I'll make sure my head is in view here. Yeah, okay. Because we have access all the time to the final screenshot of a game, I wonder, would the session model just care about having a list of the final screenshots of each game currently played? Then we can ask things like, you know, what was my average score? Instead of specifically setting the score. That would make things a lot simpler. Okay, what we're going to do is we're going to have a list of Tetris data models. And yeah, ending screens, or final game screens, whatever. We can call it something else if we care about later. So actually at that point, like the games played is just the count of that list. So, okay, what we'll do is we'll set this, we'll equal new list, come on, Tetris data model. Okay, so that's automatically going to start out as an empty list. No, whenever we make a new one. And that's almost all we need to do. And you might be thinking, well, okay, just keep that as a private variable in the Game Analyzer file. Well, the answer is no, because I want stuff like this. Public int get max score. You know, stuff like this. And then I can return final game screens dot select. Oh, I gotta import link. You know, I can x.score, and I'll take the max, right? And stuff like get average of top, and then you can, yeah. You know, so if I want the average of my top 2 games or top 3 games or top 1 game, which is done a lot in qualifying for online Tetris events. You know, you play for an hour, you take your top 2 best scores, take the average, that's your qualifying score, which that's what you enter into the competition with. So you can say get average of top and then, you know, give it a number. And then we can say return final game screens dot select, take all my scores. We can order by descending, and then we can take num. Where's my okay? So that takes the take function, just takes the top, the first 2 elements or the first 3 or whatever, and then you can average them up. Actually, the average, yeah, calculates the average, and then because average is going to return a double, what we would do is we would just cast it to an int, and then you get your average of your top 2. You know, stuff like that. So, okay, I mean, we can add whatever we want in here, but in order to fill this session model, we're going to have to go back to the game analyzer. And if we're going to take the last screenshot before you stop playing. So this is the case where you were playing and the current data model says that you're not playing, then we are going to take the last data model. Because if you recall, the last data model is set to the current data model only at the end of the loop. And so if the next data model, which data model screenshot equivalent, the next screenshot, if you're not playing, well, it's the last screenshot that contain the information, of what you're playing. So it's this case here. If you were playing and your current screenshot says that you're not playing, this is how we sort of got the final score of our game. But what we're going to do is we're going to, instead of that, current game, we're going to have a var current session, new session model. Okay, and then we're going to just do current session dot final game screens dot add last data model, and that'll add on the last screenshot to our final game screenshots of our current session, and that's fine. And then you know, down here we can say, okay, well, you're not playing anymore, so your current session dot, you know, we can get your average of top 3 scores or something like that. We could print that out and whatever, it doesn't matter. You get the hint. We don't want to keep printing these things out to the screen because that's not fun. We're going to have to do something fancy with them, but that actually wasn't so difficult at all. That was actually really easy. We're not going to test it because, again, I don't have my Nintendo hooked up. What is happening? Huh. I was hitting the wrong keyboard shortcut. Anyway, whatever. Okay, we'll build this project. Whoops. Building this solution. Just to make sure we didn't make any mistakes. And there's one more layer that, we have the current game, we have the current session. Now there's one more thing I thought that would be nice to have is historical data, like your top score absolutely ever, or something like that. And the idea would be that rather than keep track of your personal best or your run of scores or whatever, it doesn't matter. This thing would just keep track of all your scores, just everything. And that's something I wouldn't want to save on a computer, because I don't know how many people are like me, but I often format my computer. My computer is not a storage device. I don't want anything on my computer that I want to save forever. And so because of that, the pattern is to gather the data on the computer and then submit it to some online cloud-based database or something like that. Something, or even if it's like a SQLite file, which is a local database file, but just, have it in Dropbox or something like that. So my thought would be I'd push these up to something really basically free for me, like table storage or something like Azure Table Storage, just to dump these things in there. And then you can later on look at the data and write queries to get your max, or, what's the longest stretch of scores in a row that I ever got greater than 100,000 points, something like that. It's silliness. And I don't know if I'll ever use it, because you'd constantly have to have this program running to capture your data. And most of the time I'm just running without even streaming, although I'm trying to stream more these days so that I can keep record of my greatest games. So I'm not sure about the historical data. I think I'll go back and add it if I want it. I think that's fine. So looking back at the game analyzer, we're not doing a whole lot with the session. We're just saving the information. And ideally, I could run this while streaming, and OBS would be able to show the contents of the session model. That's kind of where I'm going with this. The data model and the session model would be, I don't know if I dump their outputs to text files and have OBS just show the text file. That's probably the easiest way. But that's sort of after the fact. What we want to start now is analyzing games like a person would do, and try and make a robotic announcer. So what I'm going to do is get all my stuff committed here. Where is this? I can't remember anymore. Yeah, there we go. Okay, added session model. And we'll upload that to Bitbucket. Uh-oh. Phew, I remembered my password. I've been switching all of my passwords to Bitwarden lately. I hadn't done with that one yet, so that's good. That's good. I don't know if I have the Bitwarden app on my desktop to be able to copy the password. Anyway, so here we are. We're in this state, and now we want to start thinking about robotic announcers. The idea with a robotic announcer is that it's going to eventually be some computer-generated voice based on text that I generate. So I'm interested in generating the text, and then I'm going to offload that to Amazon Polly or something like that to talk the text back to us. The idea with a robotic announcer is not only would they just read the stats. Like, we can get them to read the stats. We could get them to say, oh, current score is 80,000. But like, what's the fun in that? We want them to feel human. And I'm no like natural language expert. I'm not even a machine learning expert or really do anything with AI other than the fact that I specialized in AI in university. That tells you what university teaches you. But I haven't had to deal with AI in my career. So this isn't going to be AI heavy. Don't get all excited about that. Every time I right click to add I see this machine learning thing, and it's like, oh my goodness, Visual Studio, I'd love to click on that, and one day I'm going to, but on my own time. I'm very fascinated with AI, but I haven't had to deal with it in my career, and I'm getting to the end of my 30s. And my ability to absorb new information is getting less and less all the time. I'm not writing myself out of the AI picture at all, but we'll see. Anyway, what I want is to have an announcer to not only give me score updates, but understand the intricacies of Tetris. And one of the biggest ones is transition. So depending on your starting level, you transition to a higher level. And sometimes that comes with a speed increase. And that's basically transition. When you start at level 18, like most competitions do, you go for 130 lines at level 18 speed, and then once you get your 130th line, then you advance to level 19, which is a 50% increase in speed. Now it's different depending on your starting level. So for starting on 15, you're still going to get to level 19 at line 30, but 15 is a less speed than 18. And so from 15, when you start at 15, you will get a speed increase at 100 lines when you hit level 16. Now, level 16, 17, and 18 are the same speeds. So we don't exactly talk about the transition from level 16 to 17 or 17 to 18 because the speed doesn't change, only the colors change. So those aren't true transitions. When you start at level 12, which some competitive Tetris does start at level 12, I believe you still get an increase at 100 lines, but it's only to level 13 speeds. And I believe level 13, 14, and 15 all have the same speed. And so you can go, depending on when you start, you will get a speed increase at different line numbers. And that's what the announcer has to figure out, because that's a game-changing moment when you're playing is when the speed increases. And so I want the announcer to understand, oh, transitions coming up in 10 lines. Better get clean, because you don't want to stack too high and be in a rough situation for your screen transition. Now, the other thing that announcers do, and I'm just talking about Tetris here. That's all I'm doing is talking about Tetris. I'm not actually coding anything. But this is my intention. The other thing that announcers do is, that's not just a score check, is to understand the precariousness of playing high. So if you're got a lot of holes in your stack, that's something that's scary. And if you're high with a lot of holes in your stack, well, you're going to be topping out soon. Your game will be over. Now, I don't currently have a way of determining the height at which you're at. From a screenshot. I never built that in. Height is something else. I mean, height is relative. I could have 3 long bars stacked up on my left side of the screen, and I'm not in any danger. But the height at which I'm playing is kind of... A computer couldn't recognize that, right? I mean, it could, just not my simplistic programming. I would just say, okay, what's the highest level that I have a piece at? If it's higher than, say, 10, have the announcer start saying, oh, he's in trouble, something like that. But in reality, I could just have 3 long bars stacked up vertically on the left, and the rest of my board be clean, and I'm not in any trouble at all. So I have to figure out what I really want to do with that. But we're going to it'll be mechanical at first, and then I want to increase the level of language fluidity and get some randomness in there. Another thing I want the announcer to be able to do is to recognize my personal PB and say, oh, he's coming up to his PB, 20 more thousand points until he gets his PB or something like that. And that should be relatively easy to do. And actually, that might be a reason to have a historical model with historical games, but not from data gathered by the analyzer, just stuff that I input. So I could set my PB, stuff like that. The other thing Tetris players are trying to track is not only their overall PB, but their PB from a level 19 start, which the game will let you start at 19, and it's very hard. It's very, very hard. And I think my PB is like 64,000 or something like that on level 19. It's really fast, and it's very hard to manage your pieces. But that's a secondary PB that we want to track. So the way we're going to do this, I've been thinking about it. I'm not sure I want to do this all in a linear fashion. Like, this game analyzer is just doing things in a linear fashion. Get a screenshot, figure stuff out, print, wait for a second, then go back. What I really want to do is kind of an asynchronous kind of fire and forget messaging system, where here's a screenshot, decide if I want to do any text with it, and fire that off to a separate process, have it figure it out. And then if it's going to speak or give a score update or say some comment about the game, it'll just happen independent of the actual game analyzer code itself. The game analyzer will just keep chugging along and doing its thing. I really want a system to offload Tetris data models, screenshots. I just offload a screenshot to the announcer code, and we'll just let the announcer code figure it out. And it'll be a fire and forget. So the analyzer will just send a message. Hey, here's a thing. Here's a thing. And every so often it'll send a message. And it won't care about what the announcer code is doing. But the announcer code will be running simultaneously. And it will be figuring certain things out. So we can do that. There's nothing saying that we can't do that. I think that's a good method, because ultimately when we get this announcer to talk, I know there's some library in Windows that lets you speak text, but it's not very natural sounding. My thought was to send this to AWS. They have a system called Poly, which I can get like 2 million free characters a month or something ridiculous like that. So essentially free for my personal use. And I was testing in their system, and it's nice. I mean, they have some voices, and it seems a lot nicer than anything I could do locally on my own computer. So because of that, I'm going to have to generate text, send that to AWS. They'll render the voice, send it back to me. I'm not sure how that works yet. Or do I have to have a website open? Probably not. I don't know how they send this stuff back to me. But .NET has libraries to use Poly and all that stuff. So that's what we'll figure out. But it'll be an independent system. It won't be bogging down. Like the taking screenshots and figuring out the score is not going to be bogged down by making the robot announcers talk. It's going to be two separate processes simultaneously running. And the game analyzer can tell the announcer code, well, just send the message. Here's a screenshot I want you to just do something with. So yeah, I think that's the plan moving forward. I think this is going to be the last video called creating a Tetris data extractor. Next time we'll start creating a Tetris robot announcer. So thanks for joining me. Have a good day, and we'll see you next time.